Here, this is a SCR VI characteristics. Silicon control rectifier VI characteristics by using PSpice. We can understand the characteristics of SCR by using PSpice. So before going to the PSpice design and simulation, first we have to know the what are the basics of SCR to understand the characteristics. Okay, here. So thyristor VI characteristics. Thyristor VI characteristics in this, there are different important concepts are there. Here, this is a three-terminal device. Thyristor is a three-terminal device that is called anode, cathode, and gate. Anode, cathode, gate. And it is having four-layer PNPN structure. PNPN structure, four-layer, 1, 2, 3, 4. So anode to cathode is having four-layer structure and also three junctions, J1, J2, J3. Okay. So SCR is a three-terminal device. Three-terminal device. Thyristor is a thyristor. SCR is nothing but one family of thyristor device. So silicon control rectifier. So it is having three terminals: anode, cathode, gate. So anode, cathode, it is conducting only in the direction of anode to cathode only. It's not conducting in cathode to anode direction. So only in forward biased only it is conducting. It's not conducting during reverse biased conduction. So anode to cathode only one direction. That's why it is called as a unidirectional device. Anode to cathode only. Okay. It is having three junctions, J1, J2, J3, and it is a controlled device. Control device. The on time of the SCR, on time of the device can be controlled. Okay. On time of the device, on time of the device can be controlled by using gate triggering pulse. Okay, by using firing pulse. That is called firing angle. By using firing angle, we can control the thyristor. Okay, that's why it is called as a control device. So diode is uncontrolled device. Diode, what is the difference here? For diode 2 here, SCR, there is no gate in diode. Only anode cathode terminals. But here, anode cathode terminals and also gate. So by using this gate, we have to control the thyristor on time. But off time is not controlled. Uncontrolled turn off time. So it is not possible to turn off the thyristor. So another circuit is required, that is called forced commutation circuit is required to turn off the thyristor. And finally, it is also called as the latching device. So latching device means once triggering pulse is given to the SCR, it's turned on even though if the triggering pulse is removed. It is in conduction mode even though if the triggering pulse is removed. Understood? So latching device means if the triggering pulse is given to the this device, when triggering gate pulse is given to the this device, and it will be turned on even though if the gate pulse is removed, and it is in conduction mode only. So that's why it's called a latching device. And next, these are the different steps of modes of operation of this SCR device. First one, forward blocking mode. Forward blocking mode and forward conduction mode and reverse blocking mode. So forward blocking mode means J1, J2 outer layers of this device are forward bias. Outer layers. Okay. J1, J3, these junctions are forward bias. These layers are forward bias. And J2 is reverse bias. That's why it is called as a forward blocking mode. So J1, J3 are forward bias and J2 is reverse bias. That's why it is called as a forward blocking mode. Okay. J1, J3 are forward bias and J2 is reverse bias. And next, forward conduction mode. Forward conduction mode means all junctions are forward biased. Okay. J1, J2, J3, the PN junction and the NP junction and PN junction. So this is the junctions, all junctions are forward biased. That's why it is called as a forward conduction mode. So all junctions are forward biased. Next, reverse blocking mode. In this reverse blocking mode, outer layers become, outer junctions will become reverse biased, and inner junction will be forward biased. That means J1, J3 are reverse bias and J2 is forward bias. J1, this is called J1 and J3 are reverse biased and J2 is forward bias. So that's why it is called as a reverse blocking mode. So these are the three different types of modes of operation of the SCR. Okay, forward blocking mode, forward conduction mode, reverse blocking mode. Forward blocking mode means J1, J3. Forward blocking mode, J1, J3 are forward bias and J2 is reverse bias. Reverse blocking mode, J1, J3 are reverse bias and J2 is forward bias. Forward conduction mode, J1, J2, J3, all junctions will become forward bias. That is called forward conduction mode. Okay, these are the modes of operation of SCR. Then the important parameters is called forward breakover voltage, reverse breakover voltage, and forward voltage drop during conduction, and holding current, latching current, and hard firing gate circuit current. So these are the important points regarding to the device. Forward breakover voltage. This forward breakover voltage is nothing but even though the gate current is 0, so by using anode current, maximum value of anode current, we can turn on this device. That is called forward breakover voltage. Understood? Even though the gate current, IG current is equal to 0, the anode and cathode, here by applying the maximum value of anode current, we can turn on this maximum value of anode voltage. By applying the maximum value of anode voltage, we can turn on this device. That is called forward breakover voltage. And next, reverse breakover voltage means cathode to anode. This device can be turned on in this reverse reaction, cathode to anode. That how much of voltage is required, that voltage is called reverse breakover voltage. So forward breakover voltage means if gate current is 0, so how much of voltage, the maximum voltage is required to turn on, that is called forward breakover voltage. And reverse breakover voltage means this device is conducting during reverse bias, cathode to anode. So how much of voltage is required to turn on in reverse bias condition, that is called reverse breakover voltage. Then next, forward voltage drop. And when it is turned on, some amount of voltage drop takes place across the device. That is called forward voltage drop during conduction. Okay. And the next, holding current. This is the minimum value of current to turn off the thyristor. Minimum value of current. Latching current means is the maximum value of current to turn on the thyristor. Okay. How much of current is required to turn on this thyristor or SCR is called latching current. Hard firing gate current. So this is the another concept. Hard firing gate current. How much of gate current is required to forcefully turn on the device, that is called hard firing gate current. Okay. And next, these are the characteristics of thyristor VI characteristics of SCR. So here, this is called forward leakage current. This is called forward leakage current, and this is called forward breakover voltage. So maximum value of voltage. Here IG is equal to 0, gate current is equal to 0, voltage is maximum, anode to cathode, then this device is turned on. Okay, this is called forward breakover voltage. And gate triggered, this is called gate trigger. Okay, and then next, this is called latching current. This is called latching current to turn on the SCR. So some amount of current is required. That current is called latching current. And then holding current is called to turn off of the minimum value of current to turn off the thyristor. And this is called reverse leakage current. This is called reverse leakage current. This much of current is called reverse leakage current. Next, forward voltage drop. During conduction time, there is a small amount of voltage drops across the device. That voltage is called forward voltage drop. And this is called next, reverse breakover voltage. This is called reverse voltage breakover voltage. It is required to turn on the device during reverse bias condition. How much of voltage is required? That is called reverse breakover voltage. Okay. And next, so these characteristics from the what is the effect of gate. So what is the effect of gate means, if the high value of gate current is applied, less amount of anode voltage is required. Otherwise, high value of anode voltage applied, less amount of gate current is required to turn on the device. Okay, inversely proportional voltage and current. If high voltage is applied to the gate and less amount of current. If high voltage is applied to anode, less amount of current is required. So for example here, at forward breakover voltage, gate current is 0. So this is maximum voltage. At maximum, this is called maximum breakover voltage, VBO. So high value of high amount of voltage, but current 0. Okay, Ig is equal to 0, but breakover voltage is maximum. Then voltage is less, then current is high. So Ig is equal to 0. Ig1 is greater than Ig2 is greater than Ig3. When we are increasing the gate current, the voltage is required to turn on the device is decreasing. So gate current is increasing like this. Ig1, so Ig3 is greater than 2, Ig2 is greater than Ig1. Ig3 is greater than Ig2 is greater than Ig1. So then Ig, so 0, for example, 0. So 1 amps, 2 amps, 3 amps like this. Current is increasing, but voltage is decreasing. V1 is here more, V2 is more, V3 is more. So inversely proportional. The anode voltage is high, gate current is less. So this is the characteristics. Okay, effect of gate voltage. And then next, some important definitions. What is meant by forward breakover voltage? VBO. Forward breakover voltage. So it is the maximum anode current voltage is required to turn on the thyristor when no gate voltage is used. So maximum voltage, maximum anode voltage is required to turn on the thyristor under no gate voltage, no gate current is. Okay, that is called forward breakover voltage. The next reverse breakover voltage, VRBO, that is called reverse breakover voltage. It is the maximum negative voltage applied across the anode to cathode terminal, at which the device experiences reverse breakdown, at which the device experiences reverse breakdown. That is called reverse breakover voltage. Next, forward voltage drop. So during conduction time, there is some amount of voltage drop present, that is called forward voltage drop. It is the ohmic drop seen across the anode cathode terminals of the terminals when it is forward conduction mode, typically equal to threshold voltage of the thyristor. Okay, and these are the important definitions. Next, coming to the circuit diagram of this. So this is called of AC supply. AC supply is fed to the anode of this SCR, and this cathode is connected like this fashion. And next, this is called DC triggering circuit. This is triggering circuit is connected. And by using this, this is called gate voltage is fed to the here. So based on this, we can control the SCR turn on time. Okay. And then this can be implemented by using PSpice. Okay. This can be understood by using PSpice design. So open PSpice schematic. So new. So get new part. Enter get new part. Enter get new part across here. So what is this means? SCR means enter like this 2n 2n 2n. So this is called SCR. Place here. Okay. So to turn on this control R like this place. So we can. So this is called SCR. Silicon control rectifier. This is called anode. This is called cathode. Anode. This is called anode. And this is called cathode, and this is called gate. Anode, cathode, and gate. Understood? Anode, cathode, gate. So first we have to connect the take one resistor. Take one resistor R like this. Place here. And similarly here also place here. And take 1 volt V sine from this, get new part, enter V sine, place here AC voltage. So apply here, place here. AC voltage. And also take one VDC, that is called VDC, that is gate voltage, triggering voltage. Okay. So like this elements are, and then connect these all elements in this way. This is called circuit diagram. So in this fashion, and then next connect to here like this way, this way. So this is called gate resistance, source resistance and gate resistance. Connect like this. You connect to the gate. In this way, connect like this, and here take gate voltage is called DC is equal to DC 5 volts. Gate voltage is equal to DC 5 volts. Save alter, and then okay, 5 volts. And take here resistance. Generally, this value of resistance is maximum in the range of kilo ohms. That's why 2 kilo ohms. Let us assume take like 2 kilo ohms. The source resistance is less. Let us assume source resistance less than the gate resistance. So let us assume 500. Okay. So like this, and also take one ground at the place. Yeah. And zoom to fit. Let's zoom to fit. To open this, DC is equal to 0. 0, save alter. AC is also 0, save alter. V of also 0, save alter. V amplitude is equal to, for example, 12 volts. V amplitude is equal to save alter. And frequency, for example, 50 Hz. 50 Hz. Okay. Like this is over. And then save this. So this is called SCR. SCR. Save like this, SCR. And here, go to analysis. Go to analysis. Set up transient. Enable transient and place here. 50 milliseconds means 50 hertz means 20 milliseconds. So 1 by 50 is called 20 milliseconds. That's why it takes scale up to 50 milliseconds. 50 ms. Okay, 50 milliseconds. Analysis setup. Okay. Okay, so this is called source resistance. This is called gate resistance. Name change like this. Gate resistance. This is called gate resistance RG. Gate resistance. And this is called source resistance RS. Source save alter. Save also. Change here. RS. Save alter. So like this. Source resistance and gate resistance and SCR and gate voltage and source voltage. And if you want to display the source voltage amplitude and frequency, change the display and name both name and value. Press here, then okay. And V amplitude is also frequency also. If you want to display both name and value, and then okay. Close. These two are overlap. That's why it's changing like this. So amplitude is equal to V amplitude is equal to 12 volts and frequency is equal to 50 Hz. So like this analysis completed and also the parameters are adjusted such. And then take one here IV VI characteristics. So that's why take current marker. Take current marker. Place here. Place on the device. Otherwise, these two are series. These two are series. That's why here also it is. You can connect like this. These two are series. So then, what is the voltage current waveform? We can add observe here. So simulate, and then it will taking some time, and like this. 0, So negative waveform will display like this, current. So, so you want to display what is the voltage across this device, means it is only conducting during forward bias and reverse bias is not conducting. Okay. So current one voltage marker and place here and run, and then so this voltage only it is forward bias, during forward bias it is turned on, that's why this voltage, and only reverse bias condition it is reverse bias. During reverse bias condition it is not turned on, that's why this source voltage it acts as open switch, that's why the voltage across the diode is nothing but source voltage, that is called 12 volts AC voltage source. Here this 12 volts, it is, if it is open circuited, open circuit means this voltage source voltage is called the voltage across this device. Okay. So during forward bias it is turned on, that's why it is access. So remove this and place current marker, current I here, anode current, and then simulate. So like this. During turn on condition, the current is increases. During forward bias condition, it is turned on, and then current is increases like this. Okay. So the current is characteristics are we are getting this. These are nothing but current waveform. Current waveform is generated. This is called current wave. Current waveform is okay. And then, so here, so 10 milliamps, 20 milliamps, 30 milliamps, this current. Then in x-axis in terms of milliseconds, so it must be voltage, I versus V. So to get that, so press right click here. Otherwise, go to plot, add axis setting, go to axis setting, press x-axis, user defined, press x-axis, and here enter, for example, minus 2 volts to plus 2 volts, minus 2 volts to plus 2 volts, 2 volts, and axis variable. So go to axis variable and take one here, axis variable is called Vx1 of anode is called voltage. Vx1 of gate, G means gate. Vx1 of K is called cathode. So we need anode current versus gate anode voltage. So IV characteristics or VI characteristics. So enable like this. So then okay, press OK. So these are the IV characteristics. Okay, different values of gate voltages. So we are getting this characteristics are like this. Same as our theoretical concepts. So these characteristics IG. Okay. So like this, these characteristics. So different values of gate current. IG is equal to 0. That's why this is the maximum amount of breakout voltage. Here IG1. So somewhat greater than IG. That's why the voltage is decreasing. Here current is increasing, voltage decreasing. Current is increasing. Finally, it is turned on and then voltage. This is called forward leakage voltage. Forward condition, forward conduction time. This is called voltage drop across the device. So this is about characteristics of SCR by using PSpice. Okay. This is called 10 milliamps and 20 milliamps and 30 milliamps current. And here 1.5 minus 1.5, here 0, 1, 0.5, 1. This is called voltage. Voltage, current versus voltage characteristics. So this is about SCR characteristics.